Hi everyone, welcome to another EAStalk webinar. Today we will present the most important outcomes of the first RAS EAS Workshop that has been organized as a part of the Aquaculture Europe 2020 online conference. 300 people attended this successful event, and the next RAS EAS event will be in 2022 at the Aquaculture Europe in Rimini in Italy. This workshop was divided into 3 different topics. How do we best approach disinfection in the RAS loop? This part will be covered by Dr. Jelena Kolarevic. The second topic was where are we going with monitoring and autonomy? This part will be covered by Dr. Øyvind Fjelling Jensen. And the third part was what are the most challenging interaction between fish in RAS environment. This part will be covered by Damien Tamer. So today we have 3 presenters, Dr. Jelena Kolarevic, Dr. Øyvind Fjelling Jensen, and Damien Tamer. Dr. Øyvind Fjelling Jensen has been CEO of NFIMA since 2009 and has led the transformation, making it into the leading applied research institute in the food, aquaculture and seafood sector. He has served on several boards, including the Executive Board of the Research Council of Norway and its Portfolio Management Board for Life Science. He was chairman of the board of the University of Oslo Life Science Initiative. Dr. Jelena Kolarevic is a professor in RAS biology at the Norwegian College of Fisheries Science, University of Tromsø in Norway, and she's also senior research scientist at NFIMA and the leader of the Department for Technology and Environment in the Center for Research-Based Innovation in Close Containment Aquaculture, Control Aqua. The focus of her work with close containment systems are fish welfare and performance, the environment and fish monitoring and their interaction and automation, as well as equipped testing in above-mentioned systems. Damien Toner is a development and innovation executive at BIM in Ireland. Having worked in commercial shellfish and finfish sector previously, Damien's role at BME focuses on the new species and innovation. He has significant experience with RAS design and operation hatcheries and nursery systems, and his work includes helping companies develop new products and services for the aquaculture industry. Thank you very much for being here today. I will open the floor for Jelena. So Jelena, feel free to start presenting the first topic of our workshop.
Okay. Thank you so much, Anna, for the introduction, and welcome everybody. Thank you for joining us today. In case you have missed the RAS EAS meeting, I think this is an excellent opportunity to hear about some of the main topics that we discussed and outcomes of these panels. So I'm here to tell you something about the discussion we had on how we best approach disinfection in RAS loop. And I'm here on behalf of Jaap van Rijn, that was the moderator for this session, but unfortunately couldn't be here today with us. The way that these sessions were organized was that we had a moderator, in this case that was Jaap van Rijn, who was leading the discussion and also engaging the audience with their questions. Then we have envisioned to have one introductory presentation. In this case, it was given by Chris Good from the Conservation Fund Freshwater Institute from Shepherdstown in US. Chris has given 15 minutes talk on use of some disinfectant in the RAS loop, and I'm going to come back to some of the results that he showed and questions he raised. And Chris was then, together with other panelists, engaged in a 1.5-hour discussion on this topic. And together with him, there were also Carlo Lazado, who is a researcher at NFIMA. Aaron Lavi, unfortunately, didn't manage to connect, but was in the audience and managed also to contribute with a couple of answers. Andries Kamstra was also there for a Kamstra Consult, and Peter van West from University of Aberdeen. So before we started, or at the beginning, Jaap just wanted to actually bring to attention the fact that disinfection in RAS is such a broad topic, and that within 1.5 hours we couldn't really tackle all the questions that are out there. Because when we talk about disinfection, we can talk about the disinfection of biological material, very important thing for biosecurity. What do we take in our systems? How do we treat that material and disinfect it? Then the disinfection of equipment, different parts of the system like tanks and pipes. So there was absolutely no time to take up all these topics. That's why we specifically decided to focus on disinfection of RAS water within the RAS loop. And it was also very clear from the start that this case and disinfection can be very RAS specific, and that there are often more ways of doing it, so there is no one way. And it's very often that some methods are not very well documented. So I think there is a lot of work for the scientific European community to work on this topic further. So here are just some of the points that Chris Good presented. He presented the body of work from the Freshwater Institute, something that we've been working with for 20 odd years. He showed some results on use of ozone, UV, parasitic acid, and hydrogen peroxide. The first presentation, or the results that he showed, was summed up in this table, as you can see here, where they combine use of ozone, different doses of ozone and UV, compared to no UV and no ozone and UV. And basically what Chris just wanted to show is that you could sterilize fully your water, but that he raised a question whether actually that would be a good thing to do. And as you see here, the way that they have evaluated this disinfection is by looking at the heterotrophic plate counts. And as Chris said, this was a very crude indicator of the efficiency of disinfection, because you don't take into account viruses and other potential pathogens. They also done an experiment using ozone versus controlled, and looked into the performance of rainbow trout, which was improved by use of ozone. Ozone also improved the water quality and also reduced the number of heterotrophic bacteria. So the effects of ozones were quite clear on different levels. Then they tried to do something similar and looked into peracetic acid, and they couldn't find that it was as efficient compared to ozone. But of course, he said that they use quite low concentrations, and they need to work much more with this further. He also showed that PA was efficient when using after post-vaccination, and also there was no effect on biofiltration. He also showed some data on the effect of hydrogen peroxide, which increased the survival of salmon fry. So I think a lot of these papers are published, and you can find them out there. Then he raised a couple of questions. I'm going to try as much as I have the time to go through all these questions and discussions. The first very important question was, in close containment RAS with effective biosecurity, do we need to have disinfection on a regular basis? And what was said was basically that preventing pathogen entry here is crucial, and that once you have them in the system, it can be difficult to treat them. And as Chris mentioned, they currently are using disinfection more as a preventive method at specific vulnerable life stages when they know there are certain health risks they expect. But when pathogens are in RAS, the regular treatments might be needed, and we talked a lot about saprolegnia, how difficult it is to treat it. You need very high doses of UV, and ozone won't kill all of it. So people use, let's say, salt to treat saprolegnia. And we also see that maybe there will be a necessity to have a regular disinfection if in case some emerging pathogens show up. Then we looked at how disinfection is carried out and how much is too much, and that's really this sterilization of the water. Do we really want that? And based on the work that was done on the actually benefits of having a stable microbial community, this idea doesn't seem to be a very good one. And we also don't know how fish produced in potentially sterile water could then behave afterwards if we expose them to another type of environment, like, let's say, sea. This is one of the most important unanswered questions, and we need to also affect what is the effect on the fish. The next question was more practical. How do we do it? Where do we do it? So there is a lack of standardization when disinfection is in question. There is a paper out from Carlo Lozado and Christopher Good talking about this. They've done a survey in Norway and North America.
Jelena, may I stop you just a second?
Yes.
We cannot see your presentation slides. Can you please reshare it?
I will try. Just a second. Do you see it now?
Yes, I can see it now. Thank you.
Yes, sorry. So basically, the question that they looked into is how they've done a survey, looked into how the different industry are doing disinfection, and came to the conclusion that there is no standardization, that people in different continents use different chemicals. When it was questioned about where to disinfect, it's very obvious that if you want to get the full effect of disinfection, you should do it on the cleanest water possible, which would then mean to do it after the water treatment. But in this case, you're doing it prior to the fish tank, which can pose a certain risk as well. So that also has to be taken into consideration. We talked about disinfection in freshwater versus seawater. The only kind of big difference is that people in seawater use protein skimmers together with ozonation, which then have a better effect. And we mentioned the dose, but this was really very much dependent on the situation, system, and water quality. In the end, Chris asked about whether we should go for blanket disinfection as the best approach or just targeted. We didn't talk much about that, but we mentioned these alternative methods for disinfection. Humic substances and tannins were mentioned. This is a promising field because, as we discussed in this session, there could be a potential resistance to the chemicals that we use for disinfection. And then Andries mentioned just example of eels and use of formalin, which was necessary and where the concentrations and use of formalin was increased after some years in the production. We also talked about two important things, and that is how do we measure the effect of disinfection both on fish and microbiota, and also how do we measure the efficiency of the disinfection. So, for example, for the biofilter, the effect on biofilter, measuring nitrification rate could be a good idea, so measuring the functionality. Also, meta barcode sequencing was mentioned. That was a bit more expensive way to determine the content of bacteria, for example, and all the methods on health and welfare that we should use when we are looking into fish. And in the end, there were some take-home messages, and as you will see, there are more questions than answers, and a lot to work with for the scientific community in Europe and beyond. Again, biosecurity and preemptive measures are essential in a way to actually reduce the need of doing the disinfection. We still have very little knowledge on how far to disinfect. Do you want a sterile water or not? Disinfection questions can be system specific, so there is no one size fit all answers. Need for disinfection can change. Maybe we don't need to do a regular one these days, but maybe we will have to in the future. We need to have early warning systems that are easy to use and not so costly for the farmers to know when to apply these methods. We need to establish how disinfection affects not only biofilter, but the fish as well. And what was mentioned that actually this survey that was done, that it would be really good to have more surveys like this to basically systematize the knowledge that is out there and actually identify all these knowledge gaps that exist and that we should work with in the future. So that is all that I had, Anna, from this session, and then we can come back to the questions later on.
Thank you so much, Jelena. It was really well presented. The next presentation we have is from Dr. Øyvind Fylling-Jensen. I will share now his screen.
And you're able to see the screen now?
Yes, I am.
Yep.
You, Jelena, as well?
I see just two slides, not just one.
No, you see. What do you see now?
Now I see nothing. Now I don't see any presentation.
Me neither. It's closed.
Isn't it always like this?
When you try it, it's good. When the time comes, yeah.
No,
now it's again like that. But I believe you did not change anything in the settings, right?
No, you should.
Yes.
Now it's perfect. Yes.
I'm sorry about that. Dear audience, it's a pleasure for me being here at the EAS talk. Thank you for listening in, and I hope you're all safe and healthy wherever you are around the setting. The second part of the EAS RAS at European Aquaculture Society had monitoring and autonomy as a topic. The group participating, I was the chairman or the moderator for this session. Bård Skjelstad, who is the Chief Technology Officer of Scale Aquaculture, he gave, as Jelena also just said, a 15-minute short presentation. And with us in the panel, we had John Richmond from Movi Scotland, who is their freshwater manager. Nikos Katribousas from Avramar in Greece. He's their group genetics and R&D manager. Eleni Kelasiidi from Sintef Ocean. She's a senior research scientist working on data and automation. And unfortunately, Bjarne Hald Olsen from Billund Aquaculture, he's the chief operating officer and business development manager. He was not able to connect to the meeting. But anyway, we had a great panel and we had a good discussion. I'll try to just show you. It's John, it's Eleni, it's Bjarne, and it's Nikos here. And this is what it looked like when we had the presentation during the session. I will summarize the key findings. Board started off with the question, which is which questions are we asking or actually not asking? And the question is the market asking the right question when it comes to automation and monitoring? And are the suppliers providing the right answers? So there has to be an alignment between the questions and the answers. And the suppliers have to meet the demands from the audience and the challenges out there. A key message in his talk was it's about value creation, and it's not monitoring and automation is nothing that we do just for the sake of comfort. It's not only to reduce cost or to reduce headcount. It's about doing things that creates value in the overall production system in RAS and closed containment systems. And the key message was, of course, that monitoring and automation has to reveal challenges and enable actions so that you are building that towards creating the value. Board was of the opinion that since feed is the major cost, it's the area where one should start looking at monitoring, but I will come back to other areas as well a little bit later down. And the second part, which is important, is cleaning or automation or cleaning of pipes and systems. That is important. When it comes to monitoring and automation, it's about observing. It's about the interpretation of the data and using that interpretation to make decisions. And those decisions will lead to action that is meeting the biological requirements of the fish by improving the fish welfare, fish survival rate, fish growth rates, and also reduce the overall operating cost. The benefit and of automation and monitoring in RAS is related to species and geography, which is a key part that came out of the discussion, that you have to look at the species. There is great differences in tolerance to what say water quality between the different species, and then also the cost of operation of automated systems is dependent on which geography you're working in. And if the species is a low value species and your geography is a low cost geography, then it might not be necessary to do automation at all different levels. A key part is, of course, that monitoring and automation makes it possible to do precision farming, that you can use online or at-line real-time monitoring systems by using sensors to adjust your production, and that you actually get what Jelena said in the previous summary, early warning systems that makes it possible for the farmers to act upon the actions going on in the farming tanks and in the biofilters or in the system. A key discussion is, of course, data quality and standardization using standardized APIs and standardized sensors. Discussion was previously that ownership of data was required or actually a hindrance to putting up good automation systems. Today, the industry is moving more and more towards standardized solutions, which is also looked upon as the key to success for having open knowledge and in this monitoring way. Always look at the interaction between biology and technology. A saying is, of course, that you can't fool biology by technology or money, and that is one of the reasons that you have to understand the interface between your monitoring system and the equipment that you're using. And another part is that with more and advanced sensors and more data, and data is something that is in abundance, that you have to look at systems to do multifactorial analysis and also multifactorial interpretation. So the handling of the data based on good data quality is a key. There is always a question on what to monitor. The obvious is, of course, water quality. That's the environment the fish is living under. pH, oxygen, nitrogen, sulfur, turbidity, microbiological status, and so forth. And connecting that also with feeding and feed status monitoring, as mentioned previously. But then also other parts came out, that how does, for instance, noise or sounds in the tanks affect the appetite of the fish? And are there olfactory parameters that is being introduced into the water as a part of the cleaning or as a part of the closed systems? Are we able to measure those parts? It's always a discussion about, of cost versus benefit. But in the last part of the discussion, it's about, do we then replace the technicians, and how do we learn and how do we train the people working in the closed containment systems and build up the skills so that they're able to be in the system to add value as a key. And in the future, do we get autonomous systems and integrated systems that are able to say you can run the whole thing offhand in the part? So altogether, that was more or less a summary of the discussions we had in this session 2 of the EAS workshop. Thank you.
Thank you very much, Oyvind. The next presentation we have is from Damien. Damien is unfortunately not with us today, but he recorded a video, and I will just share it with you right now. Please, Oyvind and Jelena, let me know if you can hear the sound of a video.
Seems to be a technical problem, Anna.
I see.
I heard it was something going on, and then it just went down.
No problem. Let me open it up again.
So hello everybody, my name is Damien Toner.
Yes. You hear it?
Yep. I'm the moderator for session 3 at RAS at EAS. And in this session, we were looking at the interactions between fish and the RAS environment. And I guess when we were set about trying to develop this session, we had in our minds, you know, 4 main players within a system. Within the RAS environment, you have the fish, obviously, the water, the system, and the people who manage it. And what we were trying to do in particular was tease out some of the main constraints or challenges that we find with RAS system. And in that, we engaged and had on board some fantastic contributors to the session. So we had firstly Jelena Kolarevich, who gave a presentation on the interactions between RAS and the environment around 3 key topics. So looking at suspended solids, salinity, and what she termed RAS baggage, which was in effect what happens to fish and RAS and how that translates then when they're subsequently moved on to sea in the case of salmon smolts. So Jelena's background is in physiology and fish biology, but many of you will be familiar with her work through the Control Aqua Group, and in recent years she's focused a lot on RAS systems, closed containment systems. She's also recently been appointed as Professor of RAS Biology at the University of Tromsø in Northern Norway. So she's very experienced. She gave a really interesting presentation which outlined a number of key areas for the panel to discuss. So I suppose what Jelena was trying to do in the short time she had available was kind of outline really a summary of what are the main interactions that are happening within the RAS environment, and then specifically address some of those. So she talked about water quality, about microbiota, about production protocols, about feed into systems, about the tank environment, and very much her talk was focusing on salmon production and RAS, particularly. The first area that Jelena spoke about was suspended solids, and she gave some interesting results from research that's happened recently in Norway on the effect of suspended solids in systems. She then moved on to discuss salinity. Of course, Elena could have picked any parameter really, but she felt that it was important to look at salinity and how it affects systems, and how RAS system users and farmers are learning more about the effect of salinity on the fish every day. And then finally, she focused on this term RAS baggage, about how fish that are grown in the RAS environment subsequently perform at sea if they're moved to sea, and what kind of areas of research are required in that in future. So just to give you an overview, I'd encourage you all, of course, to go back and look at the session itself in full. I'm just giving a very brief overview here, and I'm just trying to pick up on the main points. So we were joined by Frederick Game, who is Head of Aquaculture Research and Development at Kruger Kalnes, which is part of the Viola Group, which is involved in the construction of a lot of RAS systems around the world. And Frederick has a lot of specific experience in RAS design, particularly in the marine environment. And he was well able to contribute in terms of his technical knowledge, which was a real asset to the workshop session. We were also joined by John Walden, who's Head of Freshwater Production at Greek Seafood in Shetland. So great to have somebody from the industry that on a day-to-day basis is dealing with RAS systems and interacting with them, and understands the quirks and the issues that he as a freshwater fish farmer faces with them. And then finally we had Rod Wilson, who is a professor in Exeter University, focusing on fish physiology. He gave a really interesting perspective, and certainly for me, very knowledgeable on the whole area of fish interactions with their environment and what effect certain water quality parameters have on the fish. So that was our panelists, and what we tried to do was Elena gave an overview as I've outlined, and we tried to then go through each topic in a bit more detail. And what I'm going to do now is just maybe touch on some of those. So in terms of suspended solids, it was interesting that Elena highlighted that, you know, it's not a case that we can just take a suspended solids measurement and that gives us real feedback on what's happening, because suspended solid particles differ. They're not all spherical, for example. And so Elena touched on the idea that we need to understand a bit more about the shape of those particles and how we deal with them within systems. Frederick felt that, you know, in order to reduce, for example, suspended solids down and turbidity down, you'd probably have to filter down to 1 micron, which just isn't feasible. And so what you're really trying to do is, as he termed it, develop a stasis within the system, develop a stable environment for the fish, and be that the water is turbid or not, that it's not fluctuating much, that it's not varying. And on that, you know, John commented that in terms of their production systems, they have some systems with moving bed filters and some fixed, and that it's not possible in some cases to retrofit them, and that for him specifically, turbidity was not a main issue, that the fish seem to perform well in turbid water, and in some cases it might help them. And although it might be nice to see more of your fish sometimes, that I think he agreed with Frederick's comment on maintaining that stable environment. Rod touched on the differences in organic carbon in the system and how they affect fish differently. And he highlighted, for example, the difference between marine fish and freshwater fish in terms of how they discharge urine and the variability of that, and how, for example, carbon dioxide and salinity would affect fish differently. So that was a really interesting discussion around that. We also looked at salinity, and Elena highlighted that obviously the RAS environment allows us now to farm fish in different ways, and that industry is still experimenting as to how best to do that, and that the recent pivot to more land-based farming is certainly different from the model up to now, and that domestication and breeding and things like that in relation to fish will have to change to catch up. And so we're still learning a huge amount in relation to how salinity affects fish in land-based grow-out systems. John felt that in the RAS environment that we could be unintentionally sending signals to fish at different stages. For example, if we had a nitrite spike and we wanted to treat with salt, that could be introducing salinity to the system, which might send a cue to fish. And we need to be more cognizant of how differences in the RAS environment during normal production could be sending different signals to fish. And Rod very much agreed with that from a physiology point of view. Certainly felt that the addition of salt in systems was always of benefit to fish, particularly after they had been exposed to grading or exercise or maybe high CO2, that salt was generally a positive, had a positive effect on fish physiology. Frederick commented that we needed to accept that there would be fluctuations in systems, and that the best thing we could do is try to minimize these and ensure that the variances weren't too great. And just commenting on the RAS baggage section, which was a very interesting discussion, Yelena highlighted that much of the methodologies we use in management of RAS we've taken from traditional flow-through systems, and that we might have to look again at how we do things differently and change that. And certainly Rod's feeling was that, having been at many RAS systems around the world, that we needed to ensure that staff were given the right tools and certainly trained to understand better fish physiology in RAS systems, and that was a gap that needed to be addressed. And I suppose in conclusion, all the participants felt that a lot more needs to be done to understand the interactions with RAS. And John made a very valid comment that we mine a lot of data out of these RAS systems. We generally don't dig down deep into it and access it the way that we could to tell us more about what's happening. And finally, I suppose, to sum up, Frederick made the comment that at the end of the day, we're fish farmers and that we're farming fish. And sometimes that's lost in system design and system construction. And that needs to be at the core of how we deal with RAS systems and what we do in the future. So that's just a very brief summary of some of the topics that we touched on in the session. I really hope that you have the time to go back and look at it in detail. And as I have recently done, I think you can watch it 2 or 3 times and you learn a bit more each time. So there's a lot of information there. I definitely encourage you, please, to have a look back through it. And thank you very much.
Thank you very much, Damien. I did agree with you that there were so many informations in the whole event. So right now, I would like to thank you, Yelena, and thank you, Oyvind, for presenting the summary of this workshop. I'm opening now the question and answer section. It should last for 15 minutes. We are encouraging you to ask any questions you have about this workshop, about the RAS system. The first question we have is from Magnus Faust. The question is the monitoring of parameters nowadays only online or still also as discontinuous electrochemical and photometric measurements? Yelena and Oyvind, which one of you would like to answer on this question?
I might start by answering that today. It's still so that most of the measurements or things like that is offline. It is not online. It is single. So the key is a discontinuous electrochemical and photometric analysis, pH analysis, which is taken at different times during the day, and it's logged. It's very little that is automated. The future is, of course, that hopefully we will be able to have continuous online measurements for the systems, and that the different sensors are integrated into a complete monitoring set, so that you also can do predictive analysis based on your change of data. Jelena?
So just to add to what Arvin already said, is that we still are looking for appropriate sensors for use in aquaculture, because in early days, when people started to use online sensors, they were mainly taken from the wastewater industry. So meaning that the application was completely different, that the levels that you were measuring were not as appropriate to aquaculture as we needed them to be. So very many people actually bought the systems which they ended up not using because they were not reliable for the application. But we see these days the companies that are working specifically with aquaculture industry trying to come up with tailor-made sensors for aquaculture industry that will then take into account what is the water quality that you need for your species, that you cover actually those ranges of measurements. They take into account also how you should calibrate and how you should also maintain them. So all of these questions, if one is to go in and buy new technology, should really take into account before you do so. And we're still talking about quite costly equipment. So I would assume that it's a very different situation in different parts of Europe as to what people use these days.
Thank you, Jelena, for answering the question, and Oyvind as well. You can type your questions by clicking on the Make an Announcement. I would also like to ask a question to both of you. Was it hard for you to have this kind of we have a comment from Magnus. Thank you very much for the good answers. And my question was it hard for Jelena and Oyvind to organize such an event, to find the topics and etc.?
Well, as with all events, it sticks all in the preparation and the team that you're able to put together. So the way it works is that we have the team members, and we had a discussion prior to starting off where I had formulated some questions to make the discussion going, and we had a round between the team members so that each and one could come with their expertise from the different sets. What I found very good is that we had representatives from the research environment, from the industry, from the different user perspectives, which I think is a key, that it's not only about an academic exercise, it's about how can we use the knowledge that we are gathering and turn it into value in the industry. So for me, no, it was not difficult, but it requires preparation like every good job. Thank you.
I have to say that first it was very important for us to choose the correct format of this event, because as you know, EAS has regular at their conferences, you have sessions that deal with RAS. So where new results and academic results are presented. So it was very important to us not to not to overcrowd the space, so to say, and to bring something new with this event. So then that's why we chose this format of panels and discussion, like Oivind mentioned, with the representative from different industries and R&D. So because then we could talk to the wider audience in the whole Europe, and I hope we managed to do that. And in a way, it was we had to choose 3 topics, because there are so many topics out there that we can talk about, and hence the next event in Rimini will take further on some new topics. And we also got some questions during the event. Why didn't you talk, let's say, about sexual maturation? Because we couldn't really fit everything in one day event. So we just chose certain topics that we thought were interesting to the audience, some topics where we still need more discussions, where we still need more knowledge, so where we still don't have all the answers. So that's what we went for this time, and I'm sure there are plenty of things to talk about in Rimini. I think you're muted, Anna.
Okay, can you hear me now?
Yes.
I agree with you. There is more topic to discuss about the RAS systems in general, and we are looking forward for the next event in Rimini. I would like to also add that the success of this event could not have been managed without help of you, Jelena, Oivind, as well as the YAP and the other moderator and presenters on this workshop. But I would also like to say that as the help of Astrid and Hervé was really well appreciated for this. So thank you all. I'm going to switch to another question we have. It's
Just
from
one
Anonymous.
comment. Just one, and without the audience, this would just have been a discussion between people who are engaged. So I think without you listeners and without the other participants, more than 300 at the main event, it would have been futile. Thank you.
Thank you, Oivind. I agree. The next question we have is from: what are the greatest water quality management challenges FWE and seawater in upscale's RAS system?
Yes, I can start at least. There's a lot of things to consider. So when you talk about water quality, you have both some acute instances where the water quality can be deadly to your animals, like in case for Norwegian salmon farmers. After we switched from freshwater RAS and production of smolt, where you can say that was a success story, and people really embraced the technology. And then we switched on to the seawater production in seawater RAS, and all of a sudden we had mass mortalities and issues with H2S, for example. And that's an acute problem that can occur by using those type of systems, but that the industry is currently dealing with. But I also think not just for upscaling, for all RAS systems, there is a possibility that you accumulate certain toxins in a sublethal concentrations, for example, nitrogen. And we still know very little about the effects of chronic exposure to low levels of certain toxins, for example, that we might have in cases when the technology doesn't manage to deliver the water quality we wanted, or when we exceed the capacity that the systems have been designed for. So these are just some of the aspects that people should really look and take care of. As well, the CO2 has been an issue. We are now moving a little bit the recommended values, let's say, for salmon, based on some new research and knowledge on how much CO2 actually should be allowed or should be exposed our fish to. So there is still a lot of knowledge that is being produced, and that changes the way we look at the water quality requirements in RAS systems. And also to mention, for the novel species where we don't know what are the needs for water quality, but where we don't know what are the optimal concentrations, it's actually quite difficult to design systems. So there is a certain pre-required knowledge that is needed on basic welfare and welfare needs of the fish that we need to establish before going into use of RAS systems. So just to mention some.
But also access to water, because if you don't have access to water and you have a major people living under water stress, I think it's important to look into also water sources when we are looking into this area in the future.
Thank you, Jelena. Thank you, Oyvind. We don't have any more questions, but would you like to add something more about everything?
Well, I can just say that I'm really looking forward to the next meeting, and because this format really proved to be a very good arena. We were supposed to go live and in Cork, and I assume that next time in Rimini that it will be a physical meeting, and that people will also have the possibility to meet in person and do a lot of networking, because also that's one of the points of the meetings like this, where you meet new people, where you exchange knowledge and your experiences, and that I really hope that the next meeting in Rimini will also bring that dimension, an additional important dimension to this event.
My comment is also along the webinars and web seminars are great, but if we are not able to meet and discuss between the sessions, then a lot of learning and exchange of knowledge is being missed out. So just then also, as a small reminder to all of us, take up the phone and ask a friend you haven't spoken to for a long time, how are you, and are things moving in the right direction?
Thank you, Oyvind. I definitely think that this was a tough time for all of us, but we are looking forward for the next Aquaculture Europe conference in Madeira, but also for the Aquaculture Europe in Rimini. It was hard to get the contacts with the people and to get close again, because but definitely keeping in touch with the friends and with the people that are close with are really important today. I would like to also say that we have a question from the audience, how RAS feed can help for monitoring land-based RAS systems.
I'm not quite sure if I understood the question. How the feed can be used for monitoring. Jelena, please help me.
I guess if we know and have a better overview of how much feed is eaten by the fish, we will have a better idea on how fish are doing and performing, because as of today, we still are using mainly the tables from the feeding companies that base the feeding ratios on the estimated biomass of the fish. And currently there are a number of technologies that are providing this service of measuring the biomass, but it is not a standardized method. So we still really are a bit in the dark on how appropriate is our feeding methods or the amount of feed that we are using, because we can very easily either underfeed the fish in the system and affect their welfare and well-being, or in that way, or overfeed the fish and affect the water quality in the system, and again indirectly affect their well-being. So if we find a good way on estimating the feed that is being eaten and the feed spill, that would definitely help us optimize the process of feeding, and with that reduce the costs that come with use of feed, reduce the amounts of sludge that we need to treat, and also improve the well-being of the fish. So I hope that kind of answers this question.
Thank you, Jelena. I will now read the last question for today because we are already close to 3 o'clock. Many commercial RAS perform well under their declared design capacity. How can this be better standardized?
So I would say that of course you learn a lot from the experience, and of course there are a lot of companies designing RAS systems that have a lot of experience and that should deliver what you have what a customer wants. But also we see very often that the use of system changes over time as new knowledge comes, and also the user needs to know what are the limitations of their designs really. And if you have asked somebody to design your facility for 10,000 tons, then you should know that you are able to produce 10,000 tons if you wish to do so. If not, then of course you need to have a good communication with the system supplier. So I think as we see more projects of the similar size, and also as the producers get more experience, I see that we will get as an industry better at reaching actually that stage where we actually want to be, and that the numbers quite fit with what's happening in the reality.
Thank you, Jelena. I will just read one comment from Magnus. She said, but isn't it still the complete view on all parameters is needed?
For the water quality?
I think yes, it was for the, yes, water quality.
Of course, so we, especially in RAS systems, which is such a complex environment, one should really look at all the parameters that are available, but it is very difficult, let's say in the situations where you don't have a good online sensors, you still are very much dependent on people doing these point measurements, and it is very difficult to do frequent enough measurements that would then be used in data digging processes and prediction models. So we are still not fully there, that we have that technology that allows us to have a full overview on a very frequent measurements of all the water quality parameters we would like to have. So definitely yes, that is wanted, but we are still not there.
And one comment is, of course, do not measure more than you can use and interpret, and start with the easiest low-hanging fruits and move from there. Get experience and move on.
So thank you, Oyvind. Thank you, Elena, again. It was really nice to work again with you. I think this was really successful webinar on the main outcomes of the RAS EAS event. I would like to thank you all from the audience as well for joining us today. As I said earlier at the beginning of this webinar, everything today was recorded. We will publish this on our YouTube channel, and it will be available for the period of a month. I would also like to add that the whole RAS EAS event was recorded, and we will publish the whole day recording on our YouTube channel as well. So feel free to watch it together with the recording of summary of the event from today. The follow-up email, in the follow-up email, I will send you more information about our next webinar. Thank you very much, Yelena. Thank you very much, Oyvind, again. We are really happy to be having you with us. And also, I would like to thank to all the moderators and panelists that were part of this project.
Thank you very much. And thank you for a good sharing the session, Anna. And take care, all of you. Have a nice afternoon. Stay safe. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye-bye.